Okay, continuing the unit tangent vector for the directional derivative. This is very much connected to something what we may call it as to the curvy environment. Okay, therefore you can see f is a x y z power 2 along the curve. This is very useful information. As you can see, this is saying about the curve. It's not talking about not a straight line. It's not a straight line. It's not a straight line. Okay, referring to x EU. Okay, and y 2 sine u plus 1 z u minus cos u at u equals to 0. Find the dd means it's a directional derivative here. Now first of all, solving this is something new to you, right? When you start looking at that, it's a similar to unit tangent vector, unit vector, but now the unit tangent vector actually explaining something different. This means first you try to imagine there is something at this particular point, movement of these particles in the curve, which is the curve is referred to as x y z2, and you are now going to find dr of this. Dr means it's a tangent here, and for the every cases, particular cases, over here is stated as a u equals to 0. Therefore you can see if u equals to 0, you can calculate the x easily. You will get this 1, and y equals to sine 0, therefore plus 1, you get a 1, and z equals to 0 cos 0, you will get negative 1. Now for a particular point called 1 1 negative 1, let's say they want you to find a value directional derivative at this particular point called 1 1 negative 1. Okay, for the surface of this, imagine this is a surface of f along the curve. Okay, we are using a curve here. We are going to find the directional derivative. Over here we have managed to find out the point. What about the t? Where is the t? Where is the unit tangent vector here? Okay, unit tangent vector, we have learned this before. Let me, for the t, unit tangent u, for the u is a r u with the magnitude of this. This is very important understanding. See, if the questions, there is a slight manipulation on this. Okay, when you started searching for the information on this tangent, if you don't know there is a tangent exists, I can use a tangent to find out, because the particle is moving on this line, this tangent. Therefore you can only use a tangent to identify the unit vector. Therefore in this case we use tangent unit, and nabla f is very clear. I haven't finished this r. Let me settle with this r first. Therefore how to identify the ru? Ru is xi yj zk. Okay, this is a unit vector, and I combine everything here, u I 2 sine u plus 1j plus u cos u k. Therefore, I will once I differentiate that u, I will get, remember, I want you to see this first. Why are we differentiating this? Always I put a prime, then normally student will take it for granted and see, oh, they may say, oh, this is I put it, this is a dr. Dr means it's a dx di. Okay, we are looking at the dy dj dz dk. We need to do this differentiate. When I start differentiate this, where I get eu, I get back ui 2 cos u as my j, 1 plus sine u as k. Therefore, once you plug in u equals to 0, u equals to 0, therefore r prime to the 0, you will get I 2j 1k. Can I find out the what we call tangent vector? Yes. Okay, now I 2j 1k, and this is 6. Okay, I hope that you know this is a 1 2 power 2 1 power 2, then you will get 6, and nabla f, you get a xi fy j fz k. Therefore, this one will give you 2xy z 2i x2 z2 j 2z x2 yk. Then when I substitute that f with the 1 1 negative 1, I will get the solution 2j 2k. The end, I am able to calculate the directional derivative based on the tangent in the direction of tangent vector 1 negative 1. Therefore, you will get I plus 2j negative 2k, I plus 2j 1k 6. Okay, then when you times, you just concentrate on the only the same what do you call this is a dot product, remember, it's a dot product we are referring to. Therefore, you will get a 2 over 6 2 square root of 6 minus 2 square root of 6. Therefore, you get a 6. Okay, this is we managed to solve the tangent related problem. This is a directional derivative. Okay, I know the lessons going very slow, and some of you might feel very bored with this slow pace of teaching, but I'll try, because after this thing, slowly I'll make a very fast my teaching will be in a fast pace, hopefully, because I worried whether the way that I'm teaching now, I won't be able to see your face. Sometime if I'm very fast, you may say, sir, you're very fast, but now I won't be able to see your face. But at least I hope that I'm moving in a very moderate pace. Hopefully I may say this is a very moderate pace. Okay, with that we have done directional derivative. The next stage, I would like to continue with you the next lessons. I will continue with the curl, divergent, line integral. It's a very extensive topic, but I prefer to teach you curl and curl and divergent in a very fast phase. Then I will able to finish the line integral on time, because we have 5 weeks, but I'll try to upload as soon as possible. Therefore you can revise, therefore I can able to give you some quizzes, we can have some discussion among ourselves. I will try to schedule for the discussion. I would prefer to use Zoom. Zoom you can download. I will give you a password and the password and the ID of the Zoom and the website of the URL address of the Zoom. You just connect. You are required to just download the Zoom and install into your computer, and just during the scheduled time you just connect to the Zoom and give the password and ID of that Zoom, and you should able to connect to the video conference. I know the video conference is very it will be a very extensive it will take up very extensive bandwidth. I know it's a very it's not possible for the 600 students to come in and communicate. Therefore what I can do, you can connect to the system or to the online, but please switch off don't switch on the camera. Okay, camera and sound. You just off the camera and these things, but you can still hear whatever that we are communicating. Then maybe I may communicate, but some of you might ask questions, but I will try to have some quick discussion with you. Maybe it will take up half an hour, because Zoom will provide us a free service, therefore we won't be able to use it more than 1 hour. That is one way that we can communicate among ourselves. I'll try that option first and see whether it's a workable method or not. If not, then only we have the choice. We can communicate through forum, or we can use other medium to communicate. You can communicate through e-learning forum. I will set up the forum, then you can put up something. But if each one of you ask question, difficult for me to answer all of you. But if a very relevant question, I'll take that question and I will address that in the lecture recording. I will address that in the lecture. It's easier for me to answer all the questions. Maybe you can post questions, no problem. I try to address the issues during my lecture time. Therefore, if any corrective method or any further explanations if you require, then I will able to provide to you. With that, thank you very much. We will continue in our next lessons. Thank you.